Welcome to another edition of Sudoku Invariants, where I teach you how to solve Sudoku invariants the easy way. Today we're going to look at various solving techniques, many of which are used without naming them. Last free cell is what I call cross-hatching. I am looking at each row, column, and 3x3 grid region and determining the only number that can go there. Unique candidate is really cross-hatching. Basically, you're looking at the possible numbers that can work in a particular square. And notice that in a 3x3 grid, row, or column, must be that crosses over the spot you are considering is one of the possible numbers. So you know you can rule out that number. For example, I can now put a 1 in this box here at column 6, row 2, because there already is a 1 in row 2. I also can now put a 1 in the middle or bottom 3x3 grid here and here because they already have a 1. Single position is also called naked single rather. Single position is also called naked single. And because cross-hatching gives you the same results, I never found it necessary to name this technique. Basically, all I'm doing is looking for where only one number can be put because all other numbers must be ruled out using cross-hatching. If we were to look at the 7 in column 1 and rows 11 and 12, we would know the only spot a 7 can go. This is basically still cross-hatching in my books. I looked at the rows and the columns and the grid and found only one number can go here. Call it what you like. I won't be offended. Naked triples means that you have a set of 3 numbers that can only go in 3 different squares along the same row, column, or within a 3x3 grid. 1, 3, 4, 1, 4, 3, 4. Look at column 1. I've marked in the numbers here. We're looking at a, oh yes, let's go to the next thing. Look at column 1. I have marked in the numbers here. We're looking at a naked pair. The 1 and 4 can only go in this middle 3x3 grid in column 1. But if you look at the bottom 3x3 grid, we can see a naked triple that is disguised because the other numbers that cannot really go there due to naked pair we see. We have a 2, 5, 9 combo as the naked triple. If I were to look at the naked pair above, I would be able to get rid of this 4 in row 2. column 1 because I can only have 1 and 4 in rows 3 and 6. And no other number can go in these squares, meaning I cannot also put a 4 up here in row 2. This means I must have the 8 exclusive to this square, and that in the bottom in rows 11 and 12 I can remove the 8. I can also remove the 4. This leaves us with a naked triple all by itself, the 2, 5, 9 combo. If I were to move to column 4, it does appear that we have a hidden triple. Hidden triple is where 3 numbers can only go in 3 different cells within the same row, column, or 3 by 3 grid and not other areas. But other numbers also can go in these same areas, making the hidden numbers hide within the clutter. This is why I do not use the pencil mark technique, where I put in all possible numbers in every single square on the board before doing anything else. This technique makes the board very cluttered and makes it very hard to find the naked pairs and naked triples we are looking for. Now this means I can see a 5, 7, 5, 7, 1, 5, 7 as my hidden triple. But because I have this 1, 4 combo up here, I cannot be looking at a hidden triple. If a 1 could not go here, then I could call this a hidden triple. And in column 1, because I can rule out the 1, 4 and 8, this is also not a hidden triple because it's not hiding amongst the other numbers. This is why we call this a naked triple. Pointing pairs technique. I just don't use with this name because obviously if you put a 1 in the row, I cannot put another 1 in the same row. With that said, it is a technique that simply says that if either this number or that number can go in 2 different cells within the same row called a grid, then if I put in one of those numbers, I cannot then put the same number in the other spot. This means that if I make this a 1 in row 4, I cannot make row 6 also be a 1. The rules state that we cannot duplicate the same number in any row, column, or 3 by 3 grid. This is why I'm not going to point out pointing pairs. Looking at the 259 combo, and this time including column 7, you might think we have an XY-Wing, but we don't. I cannot eliminate the 2, 5, or 9 from any of the squares I see them in columns 1 and 7. What I'm going to do is think. If I remove the 2 here, what happens? Column 1, I have what I call a toggle, meaning that I can have in these 3 squares, these patterns, 295, 592, 925, or 952. Or I can have 2 or 5 in row 12, and then in rows 10 and 11, I will have either the 2 or 5, depending on what I did in row 12. St. Olaf has an example of a XYZ-Wing I am borrowing briefly. I notice the colored squares with 1, 4, 1, 4, 5, 1, 2, 4, 5, and 4, 5. If I were to make column 1, row 5 be a 4, then I must remove the 4 from row 6, column 3. If I were to make row 5, column 1 a 5, that would make row 4 be either a 1 or a 4. However, we were instead to look at row 2, column 3, where we only have the 1, 4 pair, we see something interesting. If I made column 1, row 5 be a 5, giving me this 1, 4 pair in column 3, row 4, then I still cannot put a 4 in column 6. If I make this a 4, obviously we must remove all our 4s in this column. If, however, make this a 1, then I have a 4 or 5 pair in row 3, column 3, and a 2, 4, 5 combo in row 6, column 3. Notice, this means we have a 4 or 5 pair here and here in column 3 and also in column 1. We cannot possibly put the 4 in row 6, column 3, no matter what number we put in column 3 or row 2. This is how we use an advanced technique called XYZ-Wing to eliminate a number. I could not find in my Sudoku a better way to show that to you. So borrowed only that image for a moment. Thank you to St. Olaf University. Thank you for watching. Okay, I could not find in my Sudoku a better way to show that to you, so borrowed only that image for a moment. Thank you to St. Olaf University, or they call it college. Thank you for watching this tutorial that only focuses on techniques. We'll be solving these Sudokus for real next. Please like, subscribe, and share. Many thanks.